Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to this video. We are with chapter 6 of microwave engineering. The microwave transistors and tunnel diodes, how they are useful for microwave applications we are addressing in this particular chapter. So basically it has a background of electronic semiconductor theory. So we started with what exactly the microwave bipolar junction transistors are there, the physical structure, the various configurations, the amplification phenomena, operating principles, power frequency relations, the heterojunction type of the bipolar junction transistor also we are addressed with. From the last video, we started to see what are the details of junction field effect transistors, and on those details let us have a very short and simple problem. So here we have a problem statement for JFET. So junction field effect transistor is given to us. A certain JFET has the following parameters denoted as A is equal to 0.1 micrometers, ND is equal to 8 into 10 raised to power 17 per centimeter cube, and epsilon suffix r is equal to 11.80. With the three given parameters, we are asked to calculate the pinch off voltage. So for the given problem details, we first of all note down what are the parameters provided to us. So very first of all, we have the parameter denoted as small a. So small a is nothing but the height of the channel. So I mentioned here it is the channel height here. So the channel height is provided to us to be 0.1 micrometer. So this is 0.1 into 10 raised to power minus 6 meters, or 10 raised to power minus 7 also we can substitute in the place of a here. The next parameter is nothing but capital N suffix D here. So as this is the impurity concentration, and the impurities are nothing but the electrons for the given JFET here, or simply the flow of the charge carriers generally we take. So here I mentioned this to be the electron concentration. So electron concentration holds the value given 8 into 10 raised to power 17 per centimeter cube here. And the third and the last parameter is denoted by epsilon suffix r equal to 11.80. This is nothing but the relative type of the dielectric constant to be multiplied to be the epsilon 0 to find the complete dielectric constant or the permittivity of the semiconductor material under consideration. So having these three parameters, now we require the value. The required value is of the pinch off voltage. The pinch off voltage now can be denoted by capital V suffix P. So P for pinch off here. It is computed by using the formula Vp is equal to, we have the electronic charge Q in multiplication to the concentration of the electrons Nd into small a square divided by twice of epsilon s here. So here we can substitute the values. Q can be substituted by 1.6 into 10 raised to power minus 19. Nd can be 8 into 10 raised to power 23 we can make here for the unit of convenience. Now the numerator has the third value 0.1 into 10 raised to power minus 6. The measurement of the length, it is to be squared for a square, and it is divided by, very first of all we have 2 into the permittivity or the dielectric constant. So relative dielectric constant is provided, so it is to be multiplied with epsilon 0. So epsilon 0 value is 8.854 into 10 raised to power minus 12, or we can also get it to the form 1 upon 36 pi into 10 raised to power minus 9. So this is in multiplication to the relative value that it is provided 11.8. So the values are substituted. Now the pinch of voltage can be determined. So pinch of voltage is obtained as 6.66. So as it is voltage, we put the measurement unit to be the volts here and outline this particular value. So this way we are determined with the value of pinch of voltage for the junction field effect transistor. In the next lecture, we shall be addressing the current to voltage relationship for the JFET junction field effect transistor. For more knowledge and the details of the subject microwave engineering, you can subscribe to Ekeeda channel. Thank you.